Hello everyone. In this video, we are going to learn about the experiment wavelength of Mercury spectrum using spectrometer. Interference is the redistribution of energy when two or more waves superimpose each other. If the waves are in phase, then we get the constructive interference. If they are in antiphase, we get the destructive interference. Diffraction is the bending of light around an obstacle. The condition for diffraction to occur is the size of the obstacle should be of the same order of the wavelength. Grating. A grating is a simple glass plate on which large number of lines are drawn. The lines serve as the opaque region of the glass, and the region between the two lines serve as a transmitting part. As a result, we get a large number of slits which are equally spaced. The slit spacing is of the order of the wavelength of light. The grating element in our laboratory consists of 15,000 lpi, that is lines per inch. The aim of this experiment is to determine the wavelengths of Mercury spectrum by using plane transmission grating. The apparatus required are transmission grating, spirit level, spectrometer, and mercury lamp. This is a picture of the experimental setup. The first part of this experiment is the initial adjustment of spectrometer. You place the telescope towards the window, see the image through the eyepiece of the telescope, then using this knob, you focus the image. Next, you align the telescope with the collimator. Then you see the light through the telescope. While seeing the light, by using this knob and the screw of the slit of the collimator, you adjust the light. The last part is setting the table. To fix the table with using this screw, place the spirit level on top of the table. Then you adjust the level of the table. Once the initial adjustment is done for the spectrometer, next part is to set the grating and the collimator for normal instance position. Then after that, we will take the measurements. This video will show you how to do it. You place the rule side of the grating facing the collimator. And fix it on the grating table. Then you see the light through the telescope and adjust the position of the telescope so that the light coincides the crosswire. Once this is done, you set the vernier meter to 0 and 180 degree. Then you rotate telescope in the counterclockwise direction by 90 degree. Now you rotate the grating in the clockwise direction till the reflected light coincides the crosswire. When this is done, you rotate the grating to counterclockwise direction by 45 degree. Now we have set the spectrometer in the grating for the normal instance position. Now we will be able to see the spectrum on both the side through the telescope. Place it on the right hand side. And now you can see the spectrum. Now you place the position of the telescope so that it coincides with one of the colors Then you note down the corresponding vernier readings. Now you rotate it on the left hand side and you take the measurements for the next color. Repeat this exercise for different colors that are violet, blue, blue is green, green, yellow and red. And you take the reading on both the side, that is on the left hand side and as well as on the right hand side. This is observation table to calculate the number of lines per meter of the grating, and for this you use the readings corresponding to the green color. This is the observation table to find the wavelength of mercury spectra. Here are some of the precautionary measures. The light should incident on the rule side of the grating to avoid the diffraction of light caused by the glass plate. Make the slit size narrow and clear. While taking reading, start from the leftmost or the rightmost color and proceed it in one direction to avoid backslash/error. Try to do the experiment in a dark room. Thank you.